the previous question, we were asked to rank emissions. In this case, we're asked to actually calculate the energy of one absorption or emission. So let's take a look. It says calculate the energy in joules required to excite a hydrogen atom by causing an electronic transition from n equals 1 to n equals 4 principal energy level. Is this an emission or an absorption? So if we look here, we have n equals 1, n equals 2, n equals 3, and n equals 4. And we have an electron at n equals 1, and it goes up to n equals 4, which means that the atom gained energy, right? The atom here would be the system, and the atom gained energy because it had an electron at n equals 1, and now it has an electron at n equals 4. This tells us two things. One, delta E has to be positive because the atom is going to gain energy. The other thing is that for this to gain energy, it has to gain energy from something. In this case, it's going to gain it from absorbing a photon of light. So this is an absorption. So we know that these two things without even doing the math, because it went from a lower energy level to a higher energy level, it's an absorption, and delta E is positive. How are we going to actually calculate this? Well, we're going to have to use this equation. Delta E equals the constant, negative 2.18 times 10 to the minus 18 joules, the Rydberg constant, times 1 over NF squared, the final energy state, minus 1 over Ni squared, the initial energy state. So delta E equals negative 2.18 times 10 to the minus 18 joules times 1 over the final energy state, in this case, is 4 squared, minus 1 over the initial energy state, which is 1 squared. When you do this, you're going to get 1/16 minus 1, and that is going to give you delta E equals negative 2.18 times 10 to the minus 18 joules times negative 15/16, which is 1/16 minus 1. When you do that math, you find that delta E equals 2.04 times 10 to the minus 18 joules. And this, again, is an absorption. And it is positive because we have a negative number times a negative number, so we get a positive. But it has to be positive because it's an absorption. If you were to do the math, you could actually find the wavelength of this photon. Delta E equals hc over lambda. And you'd probably find that it is in the UV region.